Hello, welcome back. I left you in the first part of the lecture looking at molecules in a different way, ways that you have probably never thought about them before as possibly three-dimensional structures such as water, oxygen, and we also learned about different ways to show them in terms of their shape, okay? Structural formula versus a three-dimensional model. And today we're gonna really delve into the main objective, which is looking at major categories of organic molecules. And so if you haven't written that objective down, please do so now. We're going to look at each category of organic molecule and see why it is so important to life. I mean, we are what we eat, and this is why we're in my kitchen today, to really make that point come across nice and vivid for you. And so we also will have a second objective which we'll achieve, which is identifying the 6 elements most common to biological organisms. And these are listed, and I know you can copy them in your notes. Make sure that you're copying notes and you're thinking about questions that you can possibly ask when you come back to class, okay? So that's really the way this is supposed to work. Look at the questions in the textbook for chapter 3, section 2, and section 1. And normally you would have to answer them for homework. Well, today we flipped the class, so you will be listening to the lecture, and then we will be addressing those questions in class. And so I left you, I have to put a timer on because that was the problem. I realize I'm going to time this for 9 minutes and make sure that we don't go over that time. And then the second or the third video, I'll do the same. So I left you thinking about these 3 molecules, how something that you might see that makes them similar: water, oxygen, and glucose. And we'll come back to them, okay? Because those are the ones that we're using as examples, in addition to other ones that we'll get to later on. Okay, so what are organic molecules? I said we are what we eat. So if I pick up some sugar, yes, this is an example of an organic molecule. Actually, I purposely obtain foods that contain organic molecules, okay? And so each of these really represent, even the Hershey's bar, represent an example for one of these. Actually, in some cases, some foods may contain more than one example. So what are those 4 classes of 4 major molecules that make up all living things? Those are carbohydrates, proteins, lipids, and nucleic acids. Now there's a reason why I've placed carbohydrates, proteins, and lipids in green and nucleic acids in red. And I'll address that in a couple of minutes, but we're going to first address the carbohydrates, proteins, and lipids. If I said we are what we eat, and I asked you which of these 4 molecules are you continuously looking for to replace when your body uses them? Well, the answer to that are the first 3 that you find in your kitchen. You never go out shopping for food and saying, wow, I have to get my daily amount of nucleic acids. So why not? Why is it that nucleic acids are not in your kitchen? Well, turns out that if you look for your family members, your parents, grandparents, guess what? They're the ones supplying you with your nucleic acids that you have for the rest of your life, and then that you will then transfer to some of your offsprings in the future. Offsprings, biological word for children, right? So we're going to really hit upon all these molecules and look how they're similar, look at their similarities, and also look at their differences. And when we go back to class, you'll really go deeper into their differences. I could only touch upon their differences with today's lecture. Okay, so I'll put that down. So, what is it that all these molecules have in common? Well, first of all, we call them macromolecules. So you probably used a microscope sometime before, and you think about that prefix micro. Well, that's the opposite, macro. If you think about that for a minute, and you say to yourself, well, microscopic, small things, I have to look through the microscope to see them. Well, macromolecules are very large. That's the opposite. And that's really a distinguishing feature. And in the classroom, you'll identify and distinguish large molecules, the proteins from the lipids, etc. But needless to say, that's gonna require a project. The second characteristic or property that they have all in common is that they contain a special element that we'll talk about more in detail. And that special element, can you recall? C stands for carbon, good. Okay, hydrogen, oxygen, very good. So all organic compounds contain these three elements. Okay, so that's a similarity. And if you have a question about what these symbols are, if you're not, you need to brush up on them. They're on the periodic table on the inside cover of your textbook, okay? So you can look through them. Now, luckily, we do not need to know all those elements in the periodic table because our bodies are really made up of carbon, hydrogen, oxygen, and nitrogen, phosphorus, and sulfur. About 93–94% of living things are composed of these three elements, and possibly 10 more that we'll be using and talking about throughout the year from the periodic table. But so really for organic molecules, you only need to remember CHOMPS, which allows you to remember the 6 elements of life, which are carbon, hydrogen, oxygen, and nitrogen, phosphorus, and sulfur. Not all organic molecules contain nitrogen, phosphorus, and sulfur. So that's a distinguishing feature, which you will again do some research in class to identify which of those 4 molecules have these and which don't. But all of them have CHO. And we really focus on carbon, okay? So carbon is the distinguishing feature. Carbon is really why we call organic molecules organic. Okay, so if they have carbon and hydrogen and oxygen, of course, they are organic. And if not, they're called inorganic. Now, I know you're saying non-organic, but close, but not that easy with us, right? So let's go back to our original molecules that we talked about yesterday or in our last lecture. Okay, organic or inorganic? Good, very good. You said inorganic because it doesn't have carbon. Exactly. Organic, inorganic. Time is up. Did you say organic? Very good because it has what? Carbon, hydrogen, oxygen. Organic or inorganic? Time is up. If you said inorganic, correct. Okay, now why is carbon so special? Well, we have to review a little bit something that you learned possibly in middle school, which is called atomic structure. If you recall, we used to draw carbon atoms using the Bohr's model, which we use a central area called the nucleus. And if you recall the positive and the positive sign and the N, what did they stand for? If you said protons, you were correct. Neutrons, correct. And how about the really important ones for life? These are number 1 for us. Electrons, yes, they look like a little negative sign. And the carbon atom, when you look at the periodic table, you can determine how many protons it has, neutrons, And then the number of protons is also the number of electrons. So if you have 6 protons, you have 6 electrons. The electrons that are really important are the ones on the outside valence level. Those are the ones that allow carbon to interact, combine, okay, with itself, okay, which is visible in this model here, where one carbon atom combines with another, bonding, okay, and in this model, you could actually break the bonds, which in real life we do that, okay, when we digest food, our body's literally doing that, breaking the bonds where energy just is released, and really that is life, breaking down these molecules, getting energy, because without energy, can't do anything. And then there's some times where your body puts molecules back together, okay? And that also requires energy, just like it's requiring energy from my little demonstration here, okay? So, believe it or not, this is a linear molecule of carbon, but you may think it's zigzag, but we call that linear because it has a straight line. So carbon's ability to do this goes back to the structure of its atom, okay? So there's 4 electrons out here, and if you recall, oh, time is up. I must stop now and stop this video and do the second part.